Hey, what's going on, guys? So today we're going to be looking at special segments in a circle. So essentially, we're going to have different types of intersections looking at circles, and there's going to be a special relationship between the lengths of these, or the parts of the lengths of these segments. So let's go into the first type. When you have two chords intersecting in a circle, special relationship here is if you do this part times this part, so A times B, it turns out that it actually also equals C times D. So let's look at a couple of examples. So on example 1, again, we have two chords intersecting in a circle. So it turns out that this part times this part, so 10 times x, which is 10x, equals, then we have this part times this part, 15 times 14. Okay, so this goes to 10x equals 210. Divide your 10 over and you get 21. Okay, on number 2, so again, we'll have this part times this part, so 4 times 5x minus 1 equals this part times this part, which is 36. Okay, so you can distribute the 4, or you can actually divide the 4 over now and get 5x minus 1 equals 9. Add your 1 over, you get 5x equals 10. Divide that 5 over, and you get x equals 2. Note, though, it actually asked you to find BD. So we found x, but it wants BD, which is this whole length right here. So to find BD, okay, BD is this whole segment right here. So now that we have x, we can go find this part by plugging in 2 for x. So we get 5 times 2 minus 1, which is 10 minus 1, which is 9. And then this part right here is 4. So adding those together, BD is 9 plus 4, which is 13. Going on to the next type. So we have segments of secants. So we have two secants here. So the special relationship here is that you could do this outside part A times the whole part A plus B equals, and then same thing for the other segment, C times C plus D. So an easy way to remember this too is A and C are on the outside of our parentheses algebraically, and these are the parts on the outside of the circle. So let's do an example. So for 5, we'll have 8 times, and then it's this whole part. So 8 times 19 goes to 27. And then this whole part is x plus 9. So we'll have 8 times 27 equals 9 times x plus 9. So 8 times 27 goes to 216. And that will equal, distribute this 9, 9x plus 81. So now subtract your 81 over, and we get 135 equals 9x. Divide your 9 over, and we get x equals 15. Moving on to the last special type, segment of a tangent and a secant. So we have one tangent here, touches the circle at one point, and a secant here. So we get a squared equals b times this whole part b plus c. So let's take a look at example 9. So solve for x. So we take that tangent segment right here and square it. So 24 squared equals 18 times this whole part is x plus 18. So 24 squared goes to 576. That will equal 18x plus 18 times 18 is 324. Subtract your 324 over, we get 252 equals 18x. So lastly, divide your 18 over, and you get x equals 14. And that is it, guys. Thank you.